Exponential graphs have got a particular characteristic that involves numbers that go to the power of other numbers. So you can see that numbers that have got a power usually go very big quickly or go very small quickly. So let's have a look at what these exponential graphs look like. First of all, they have a formula that goes y is equal to a to the x. Now that x is the power or the exponent, and a is usually a number. So we can have equations like y is equal to 2 to the x, or y is equal to 5 to the x, numbers like that. So they're called exponential graphs. Now let's have a quick look at how they're done. Once again, at this stage you should pause the video and go and take your calculators and see if you can work out the values that are missing down here. And then turn back the video and we'll check and see if you are correct. Alright, let's have a look at the answers for these ones. Now this would be 2 to the minus 3, which gives you 1/8. We'll leave these as fractions. You get 2 to the minus 2, which is 1/4. This one would be 2 to the minus 1, which would be 1/2. 2 to the power of 0 is equal to 1. Now these ones we know are a lot more familiar. 2 to the power of 1 would be 2. 2 squared would be 4. 2 cubed is 8. And 2 to the power of 4 is equal to 16. So we'll plot these now and see how we go. So remember, this is the equation y equal 2 to the x up here. So we'll put our x value here, our y value here, and we've got to range our numbers through from -3, so -3, -2, -1, then 0, and then 1, 2, and 3. And I'll change our colour once more, and we'll plot them. So when it's -3, it's an 1/8, so it's very close to the y-axis. At -2, it's 1/4. So we'll put 1/4 here, and I guess what we really need to do, which I forgot to do, is just to put in the numbers up here. Now that's interesting because we've actually got to go up quite high. We're going to run out of numbers here, so we're going to go, say, these steps like that. But you can see we've got to have 8 and 16, so it's going to take off somewhere up that axis. We should really go right up to 16, but we haven't got enough space for it. So plotting these points again, we got to -1, so when x is -1 we have 1/2. When x is 0, it goes through 1. When x is equal to 1, it goes through 2, and you can start to see this goes off very quickly. At 2 it goes to 4. At 3 it goes to 8. Now 8 would be up here somewhere. And then of course if we went to 4, it would be right off the page. So let's plot these and see the shape of the graph. So we'll try and get it. Remember, it's going to get closer and closer and closer to the x-axis, and then it's going to take off very, very fast. It's what they call exponential growth, really very fast growth. And it actually doesn't touch the x-axis at any point, and it takes off like that. So that's the graph of y equal 2 to the power of x. It's called an exponential graph. Now I'm going to put up GeoGebra, and let's type in what this looks like. So we're going to put in y equal to 2 to the power of x. Press enter, and there's our exponential graph. And maybe just for interest, let's see what happens when we get y equal to, say, 5x, 5 to the power of x. Let's see what happens there. Alright, so look how it's getting narrower. So if the number gets bigger, it gets closer to the y-axis. So I wonder what would happen if we put in, let's say, y equal to 0.5 to the power of x. I don't know whether this will work. Yes. Oh, look, it reversed its position, which is very interesting. So you can see that there's a lot of things that can happen with these exponents. So even though it reversed, it still had that very small value on the x-axis and then took up very much as it went along that x-axis. So that's very interesting that all of this here would just be reversed around. But notice one interesting thing, and that is that, just going back to that GeoGebra, the if I can, I'll just close that. We'll save that. Yeah, notice that it all goes through this point here, all of them. I wonder if that happens all the time. That's worth experimenting with.